see you all. Welcome to Unit 3, Lesson 4, or U3L4. So as usual, please look for the tasks to complete for U3L4. I literally just linked it to the homepage, so you might have to refresh it. You can find it either on the weekly calendar or under assignments. The lesson's complete. I just haven't been able to put in the last little bit of homework, but it'll be a Hewitt reading. I'll add that in later on, hopefully within an hour of our class ending. But as usual, we'll start off with a little breakout room chat. The question today, oh, here's Noah. Let me let him in before I post this to the chat, so I don't have to do it the one time. Or not, I guess he's joining very slowly. Okay, the question is, if you were famous, what would you be famous for? Would you want to be a famous author or a famous musician or a famous chef or an actor or whatever comes to mind? All right, we'll come back together in 2 minutes to share. Rooms are open. Thanks a lot for sharing, everybody. Next task, as usual, is homework check, really quick. You just had to make sure that you have submitted your local climograph graph and completed the reflection on it. Hopefully most of you got that done in class. Then there was the climograph worksheet part 2, which I am seeing 14 attempts on, and looks like we're feeling pretty good about responses. Most of it's free response, but a little bit mixed about the inches and stuff here, but again, I'll look over that. Yeah, I'm trying to remember what the 2 cities were, right? It ended up being, I don't remember, it was Florida. Wasn't there one that was Florida? And the other one was in Wyoming, right? I think it was like Cheyenne or something. So, all right. And then there was the reading reflection on Hewitt 25.7 as well as 26.5 through 26.7, all about wind. We're going to review that in a second. But again, responses are looking great. I'm seeing 12 attempts. And yep, we're going to be exploring the Coriolis effect in class today with an activity and also looking at some weather stuff. So any questions, anything you got stuck on or were unsure about with the homework? We wanted to review. All right. Oh, Camille?
So on the quiz, there was a question about like the air going to the hallway or something coming to the classroom.
Yep.
How does that one work?
Like, so I'll have to go check. Hopefully there wasn't a typo or anything. I've been discovering more and more typos in my questions. But what I was trying to get at with that was that imagine you're in a chemistry classroom, right? A sealed room. A lot of chemistry classrooms have vents because there's usually some kind of bad experiment going on there. You don't want the fumes building up in the room. And so air is being vented out of the room, right? And so what I was trying to get at with that is that if there's lower pressure inside the room, right? There's literally less air inside the classroom, which means that if you were to suddenly open the door, what would air do?
Oh, it would rush out or it would come in.
Yeah, if there's less air in the room, more air outside, air is going to come in. And so that's the key concept, is that air always goes from high pressure to low pressure, right? Think of wind as basically filling space, right? Wind is air moving from where there's a lot of it to where there's not very much of it, which is a confusing concept, I know. But that's what I was trying to get at with that question. I know it was a little weird. So it was challenging, but yeah, less air in the room, more air outside, open the door, air is going to come rushing in. And some of you might have experienced this. If you've ever been in buildings where sometimes you'll notice it's like a little hard to close the door, like the air fights you, or you open a door and it comes flying open, pushed open by the wind. That's because of a pressure difference between where you are and outside or wherever you're going, which is kind of interesting. So yeah, it's a good question. I don't know if that helped, Camille, but that's the idea is that's going to come rushing in. So anything else? All right. Just as quick review of the chapters that you read, I wanted to show you this short little 1 minute 45-second video all about the Dust Bowl.
This fall on PBS, they had come to the far edge of the Great Plains in search of a new beginning. in the last place in America where a family could claim a homestead and build a future.
We had the best crop that we had had in 1929, and everything was looking up.
A sea of grass, once the domain of Indians and buffalo, disappeared beneath the blade of a plow.
I saw the whole country transformed in the sunset glow. All the brown prairie turned to gold.
But then, it was as if the land rejected them. The rains stopped, and the winds came.
We saw this cloud coming in, black dirt. And I'll never forget my grandmother. She said, "You kids run and get together, the end of the world's coming."
It came like a black wall, a tide of destruction that crashed over the broken plains, choking the life out of everything in its path.
You never really escaped the dust. It always found its way in, and that's, I think, what drove people crazy.
Some would pull up stakes and move on, but most stayed, always looking to the promise that next year would be better.
We were just too selfish, and we were trying to make money, and it didn't work out.
Ken Burns tells the story of a generation that was buried and what it took.
All right. So, show of hands, how many of you have heard about the Dust Bowl before at all? Yeah, if you've taken a history class, you've probably heard about it. So it was literally just wind doing what wind does, wind erosion. But human activity, we basically completely destabilized the topsoil in massive amounts of land in the central United States. And it literally kicked up huge clouds of dust that were distributed literally all over the world. And we'll kind of explore a little bit about that later. But pretty crazy time. All right, I'm gonna share my screen again here just to cover a few slides quickly, and then we're gonna delve into 2 activities today. Okay, can I just get quick verbal confirmation? Everyone's seeing Dust Bowl on the screen?
Yes.
Yeah.
Yeah, we can see it.
Look at that. So imagine seeing that like wall of dust and dirt coming towards you. And if anyone's been out to the desert, like in Nevada and stuff, you're already aware that sand and grime gets in everything. So I can't imagine suddenly having to live around this constantly. And blotting out sun, crops wouldn't grow. A lot of people were starving. It was not a good situation. So it's something we definitely learned about. So as Camille was asking about, one of the key concepts to take away from this chapter is the idea of what actually generates wind, right? Why does the air that we are living in move, right? It's not like there's something out there pushing it. And it's simply because of molecule distribution, right? That air will sometimes get packed together really tightly, high pressure. And when that happens, it's gonna move until it can be more spread out, right? Air is always going from where there's high pressure to low pressure. So if you ever feel wind coming against you, it's usually because there's a lot more air in front of you and there's less air behind you, right? It's following that track, it's moving in that way. And the bigger the difference between these two things, the more powerful the wind is, right? And so that's when we get these powerful windstorms and stuff, is when you suddenly get these huge pressure differences. And that's, you'll often hear people say that, right? When rain is coming, they'll say, oh, the pressure's dropping, right? And that just means that you're suddenly gonna start getting a lot of wind flooding into wherever you are. Interesting to see too that with temperature starts to drop and you've got really fast winds, you have an extremely high risk of developing what's called frostbite, which is pretty freaky. I've got a picture of it here, but it's basically where your skin freezes and is unable to deliver oxygen to the living cells that make up your skin. You have a layer of dead cells on the surface, which is okay, but then you have, they call it frost nip, which is kind of funny, superficial frostbite, and then the scary stuff where you're literally tips of your fingers, tips of your toes, tip of your nose is where this happens a lot, your extremities. Will turn black. That's basically necrosis. The tissue is dead. So it's like you're rotting, but you're still alive. So anyway, definitely want to avoid that. And so obviously extremely high winds in extremely cold places, not a good combination if you don't have proper covering. This is also why when you see climbers on Mount Everest, they are covered from head to toe. So I tried to make this as confusing as I could with the questions, but basically this image explains it all. You can have wind moving in 2 different directions if you're on the coast, and we experience sea breezes a lot here in Pebble Beach, just because we've got a lot of low pressure areas behind us with Salinas in that area. So wind is usually coming off the Pacific, keeping our area very cool, regardless whether it's day or night. And then land breezes can go the other way often, usually during the nighttime, I think due to temperature changes or what's happening over land. But again, they don't have to follow that pattern necessarily. It's more just the direction that the wind is blowing. So this explains weather patterns all over our planet, but the whole idea, again, is just you got to remember that hot air rises, okay? That's the key thing to understand, is that when air is on the surface, it warms up, and so it rises up, those thermals, and then obviously then cold air falls. And so we get these gyri, right? These circular areas where air is just constantly cycling, right? You have warm air headed towards the equator, then it rises up and cools down and drops back down the temperate zone. Another reason why, again, it tends to be very low pressure and very hot in the equatorial areas and a little more varied where it's temperate. Sailors are very aware of the winds, right? Because they used to be very dependent on the winds to get around, right? So sailors always do to catch the westerlies or the northeastern trade winds, but they also knew to avoid the equator at all costs, what they called the doldrums, where there wasn't a whole lot of wind. You could get stalled in there, potentially, if you were a sailor. What we're going to explore today in an activity is called the Coriolis effect, which I know is a little confusing, but it's all about perspective, right? So it's the idea, so they define it as the deflection of moving objects when they're viewed in a rotating reference frame. So it's just your view, right? So here is, for example, two people sitting on a circular base, and they're going to throw the ball in a straight line, one to the other. If you were to start rotating that same base, this person, when they throw the ball, even though the ball continues to move forward, right? So that's the true motion of the ball. The way this person sees it, their perception, if they were actually watching, it would appear to bend, right? Because it would look like this person moved away from it. But that's just because their frame of reference is rotating. Again, this isn't the best diagram to explain that, but I'm hoping we'll do an activity today that will clarify this a little bit, that you'll literally put it into effect. In ocean currents, we'll talk more about this later, but very similar to wind, the ocean is constantly moving due to not necessarily pressure. It's more driven by temperature this time, where you see warm waters and cold waters. But it also makes total sense that we see warm waters mostly in equatorial areas, colder waters in the northern and southern hemispheres. Kind of interesting to see that, so California coast, as beautiful as it is, water tends to be pretty cold, and that's because we're getting all this ocean water that's coming from the northern area that got nice and cold and then runs along our coast, whereas a lot of parts of the East Coast have the exact opposite, right? They have ocean water that was warmed up near the equator and then travels up. And so if you're in the Carolinas or something like that, ocean water tends to be a little bit warmer than what you would experience in California. So it just explains that a little bit. All right, we'll be exploring more and more about this in our next few lessons. Any questions or comments on that? Okay, then the next task is a little activity. You're going to be drawing and cutting out some stuff to simulate the Coriolis effect. So on the tasks to complete, this is step number 4. Click on that assignment right there that says stimulating the Coriolis effect, and it'll take you to an assignment that looks like this. Oh, I guess I don't have it open yet, so let's go find it. Oh, sorry, it's a lab activity. Here we go. Once again, I tried to put the instructions in here as clear as possible. You're not using Google Sheets this time. You're just going to be drawing. Essentially, what you're going to do is draw the northern hemisphere and the southern hemisphere on a piece of paper. You're going to draw in the continents in simple form. You don't have to copy this perfectly, obviously. And then you're going to stick a pin in the middle after cutting it out and rotating it. So anyway, this is what you're going to end up with. Something like this picture on the bottom, so you can always refer back to that. I made demonstration videos for each, so I encourage you to actually open up those videos and just work along with me as I do this. First one's about 7 minutes long. I think the second one's about 5 minutes long. I'll be here listening. If you have questions or need help, you're going to upload a photo of what you make as that part of that quiz question, and then you're going to answer some reflection questions based on what you made. So let me know if you're curious about if there's material you might not have, or if you're not sure what to do for a certain step. But otherwise, I'm going to time for 25 minutes, and we'll come back together to check in. Go for it. Let me know if you need help.